So welcome back to AQA past paper, and this is the non-calculated further mathematics paper. This is part 2, and last time we left off with question 5b. So we have to work out 107 squared minus 97 squared. Well, for these consecutive questions, it's mostly requiring you to use the above to solve the answer. So in this case, we could actually think of a number that fits in x in this case. So that would be 100 plus 7 and 100 minus 3. There's 97 and 107. So that would fit in the pattern. So now we know that x is 100. We can do this. So the answer will be 20 times 100 plus 2, which equals to 102 times 20, which is yeah, that's the answer. So the answer would be 2040. And for the otherwise part, you can actually use another method, and that would be the difference of squares method. A plus b times a minus b equals a squared minus b squared. So this actually fits that as well. Let's take a look. So 107 squared minus 97 squared. So that's the question. If it's difference of squares, then it would be 107 plus 97 times 107 minus 97, which will leave you with 10 times 204. So which is 240, and that actually matches the previous answers. So that is two ways of solving that particular exam question. So now let's proceed to the next one. Simplify that expression. Well, we know that if it's a power of a bracket, then you just basically multiply the powers to the numbers. So what you do for that one is 3xy 3xy to the power 5, and that to the power of 4, I think. Is it? Yeah, to the power 4. And yeah, that's not particularly good, well displayed. So that would be 4 times each power. So 3 to the power of 4 times x to the power of 4 times y to the power of 5 to the power of 4. Okay, so that would express into that one is 81, that one is x to the power of 4, and that one will be y to the power of 4 times 5, which is 20. So that would be the final answer for that question, and it's just a 2-mark question, so it's not going to take you long. Now expand and simplify that expression. So it's clear that y squared. It's just a copying question that takes long for this paper. If when you're doing this, you wouldn't need to type out things, and that would go so much quicker. And I'm actually not doing the question right now. Instead, I'm just typing it onto the screen so that I can edit it. So this is the question that he's asking. What you need to do is do the crab's claw thing, or to do the well, this one you need to use the crab's claw, I guess, or the column multiplication method. So that would be 2y cubed times minus 10y squared. That would be plus 4y minus 3y squared plus 15y, then minus 6. So that would have to be simplified to that, minus 13y squared plus 19y minus 6. So that would be a cubic formula of well, after simplification of that. So that's simplify this to expand that expression and simplify it. Now this is question 8. Curve has equation x to the power of 4 minus 5x squared plus 9. So now you have to differentiate that to get dy over dx. So that would be just simply 4x cubed minus 10x. That's it. So it's 4x cubed minus 10x. So we'll type it out. 4x cubed minus 10y, I think. X. Oh joy. Yeah, that's that. So that answer would be 4x cubed minus 10x. Now you have to work out the tangent of the curve, and I have a whole video about this question. So if you don't know how to do it, watch a video, and that would simply be so if x is equal to 2, I believe, I have a short memory, or bad memory rather. So if that's that, then because we've differentiated the equation, so we can simply say the gradient m will be equal to 8 times 4, 32 minus 20, so it's 12. Okay, so the gradient is 12, so the equation will be y equals to 12x plus c. We don't know c. What do we do then? So now we don't have a point, we just know that the point is x equals 2. But look back to this, we can find the y value by inserting the x into it. So let's do that. That would be 2 to the power of 4 minus 5 times 4 to the power of 2 and plus 9, I believe. Let's check. Yes, that is true. Wait, why did I put 4 there? Never mind, you know what I mean. So 2 squared is 4 times 5 is 10, and that 2 to the power of 4 is 16, and so is 16 minus 10 plus 9. That one is a typo again, so I will fix that before you shout at me in the comments. Okay, here we go. Okay. So now what we do is just to simplify that expression, or just as you know the classic math, just add them up. So it's 15. So we know that y is equal to 15. So now put this value into the y position, and we've got x equals 2, so I'll just do the lazy boy method, copy and paste. Well, and I need to add a bracket onto it so that you don't confuse, and that would be 15 equals to 24 plus c. So now that we know, you can rearrange it so to get c is actually equal to negative 9. So c would be negative 9, so the equation of the tangent will be y equals 12x minus 9. So that is the equation for the answer on 8b. Okay, so that's simple. And question 9 currently is solve that equation. So if it told you to use this kind of format, then it's probably a thing that you need quadratic equation for. So let's do that. So now we know that a is 1 because it's 1x squared, b is 6 because 6x, and c is 7. So that's convenient. 167. Okay. 167. Just so I don't forget it. 167. There we go. So what we do is minus b, then root plus or minus. Don't forget that. Root b squared, which is 36, then minus 4ac, which is 4 times 7, 28, over a number which is 2a, which is 2 times 1 is 2. So that is simple. Now we know that this root will become 36 minus that would be 8, root 8, I think. So root 8 is also root, well, 2 root 2, I think. I use a lot of I think because I actually didn't look at the answer key while I'm doing this, so I hope I'm right. And we know it's 2 root 2, and this is negative 6, 6 plus or minus over 2, and we know that we can cancel out things if they occur in both locations, or if we factorize this. So we can actually factorize this to 2 bracket 3 plus or minus, it's negative 3 because it's negative 6, so plus or minus root 2 over 2. So the 2 actually cross out itself, so that the answer will be 3 plus or minus root 2. So that is the answer for that question. Let's go on to make x the subject of the formula. That would be just rearranging. It's more like similar to linear equation, except it's with algebra. Well, linear equation consists of algebra anyway. So actually we can multiply both sides by a minus x, so that a plus 2x is equal to n times, we check, it's a minus x. So after that step, we'll expand the bracket so that it's a bit easier to deal with the like terms and things. So now we want the x term together, and what we will do is so that it goes to 2x plus nx will be equal to na minus a. Looks normal enough, yeah? If you can follow through that, then you can just factorize either single side or both sides, it doesn't matter. I'm gonna do it single-sided, so we will have a value, not x but 2 plus n will be equal to na minus a. So the answer of x will be equal to na minus a over 2 plus n. Okay, so that would be that question explained, and that is the answer for that. So let's run through to the next one. Here is a sketch of a cubic function f(x), and notes the three intersection points are labeled. So we have to find three linear factors of that cubic formula. So what is a factor? A factor is what makes that equation, and if we know that y will be equal to 0, that means that fraction or that factor is going to be be 0 at that point. So for 0, we know that anything with 0 is that a factor, if x is 0, it's gonna be 0, right? So a direct factor of that cubic will be just plain old x. So x is one factor for that question. Then now go to 3. If x is 3, then there's a factor that makes it 0. So what makes 3 0? Minus 3 makes it 0. So if x is 3, this is a factor. Okay? Do you understand that? Hopefully you do. And now back to here. Another point is negative 5. So when x minus 5, well, x minus negative 5, which is plus 5, will be a factor. Okay? Does it sound alright? Yeah. So as long as if x makes that x add together with that number is 0, then that is the factor. So a factor consists of normally 2 terms, okay, and sometimes with 1 term only. So that would be the answer to those. And if you don't understand, then it's basically when x is 3, it's 0. So this is a factor because it intersects the x axis, so the y value is 0. Same goes as this one. At this point, x is negative 5, and add 5 to 0. So it again crosses that x axis, and this one is just the origin one, so it's quite straightforward. So now we're given that f(x) equals x cubed plus bx squared plus cx. Now we need to find b and c, so that is quite, well, simple. Because we have those 3 factors, and we know that cubic formulas only have 3 factors because there's only x cubed. So we just multiply these 3 together. First do these 2 because they look a bit more complicated. X squared plus 2x minus 15, then the whole thing times x, because we have another factor called x. So let me do the calculation. X cubed plus 2x squared minus 15x. So that is the equation for that function, and so that function is actually in that term. So we can just do the thing that we do when we is it all plus? Yes. B x squared plus cx. Okay. Yes. Copy and paste correct. and now we just match them. So 2x squared equals bx, and cancel out the x together, so b equals 2. I hope I don't need to explain that again, because you're doing the exam now. And again, this c will be equal to negative 15. So that is the answer to this question, and you just need to fill in the blanks. And now it's matrices question. Joy. I sure hate doing matrices on a laptop or a computer, whatever. So now it's x31y, x31y, then it's x minus 4, not minus 1, minus 4, answer is 4x and 8, I think. Yeah, that's true. And now I just need to equal sign brackets. I can't use a mouse properly, so that is terrible. So now we can make equations out of them. So x squared minus 12 will be equal to 4x. So that's helpful, I guess, in some ways. And x minus 4y will be equal to 8. So that is, well, not helpful because there is a y there. So let's solve this one first. So we can rearrange that to x squared minus 4x minus 12 is equal to 0 because we moved the 4 away from this side. So now we have a zero equation with a quadratic. Guess what? Quadratic formula time. And I'm not gonna copy that. Look at your equation sheet. So minus 4 minus 4 plus or minus the root of 16 minus 4ac, which is actually a plus 48 over 2. So let me draw that out. Roots plus or minus that. So now what we need to do is just to do the calculation. 16 plus that is actually 64, I think. Yeah, 64. Root of 64. Who can do that? 8. Okay, so that's quick. 8 plus or minus 4. Do that there, and over 2, and again you can factorize it. If I'm writing with a pen, I bet this will go so much quicker. 2 plus or minus 4, then bracket over 2, and you cross them out so that the answer is 2 plus or minus 4, which is 6 or minus 2. So at these two, when x is these 2 points, then it's agree with this equation. So now we have actually 2 or solution for each x and y, because when x is 6, we know that minus 4y is equal to 2. So y is actually equal to negative half minus 1/2. Okay, so that is one solution of y. That is just one of them, and trust me, there is more to come. And if you put negative 2 into the equation, then we'll get that it's actually minus 4y equals to 10. So that would be conveniently 5 over 2, negative 5 over 2 is, yeah, I'll do fraction and you simplify that yourself. It's actually 2.5, I think 2.5, and so these are the pair of answers that you need to write, and remember to put the answer down as a pair of answers, like x equals something right here and y equals something here, then x equals something here, y equals something here, and the horizontals are pairs, and you can leave them in boxes so that the examiner know which box correspond to which one, so that he don't mess you up. It's just presentation, really. So now we have to solve y. Oh joy. See, let me think. Oh, so that is quite simple actually. Because this is a factor of y. Well, this is y is a factor of this thing. So we can just divide this part to the other side so that it's 8 over root 3 of plus or minus 1, I can't remember. See, 8, and under it is root something. Root 3 minus 1. 3 minus 1. And I have the root on my pen. So that is the y. Oh my. Never mind. There we go. Larger is more stable, I think. So now we have that to do, and we know that we need to give it in this form. So how do we solve that? Well, one of my videos in like chapter 2 or something said how to rationalize numbers. So that would be 8 times root 3 plus 8 times 1, so it's 8, and the bottom will be rationalized, and I'm just doing it quickly. I think you should be able to rationalize it yourself, so I'm not planning to do anything more than just do it with you. So that would a plus b and a minus b will make 9 minus 1, which is 8. So 8, 8, 8, we know what happens, and kill you, and kill you. So now we're left with, remember, this one remains as 1, so it's root 3 plus 1, or in this case 1 plus root 3. So a is 1, b is 1. Okay, so that solves that. Now go to question 14. 3 more questions to go, and I think I've used about half the test. That's a lot. So now we have ABP. ABP and ADQ are tangents of the circle, which means they are straight lines. C lies in the circumference, or on the circumference. Then we have to prove that y equals 2x. Well, now how do you do that? Well, it's quite simple. We just need to prove that BC is parallel to AQ. No, you don't. You don't actually need to fuss about those things. You just need to know circle theorems. So, because these two are radiuses, so OCD is actually angle X. So this is angle X, and at this point you have to pay real attention and make notes, because it's going really crazy really quickly. And now we know that because a tangent makes perpendicular with a radius, so that this PBO is actually 90 degree. So we know that CBO is 90 minus 2x. Fair enough. And because this is 90 minus 2x, and again radius makes that BCO is 90 minus 2x. Now we've got this angle, and because of the rule angles at center, well, first of all, say BCD is actually x plus 90 minus 2x, which is 90 minus x. So this is 90 minus x. This angle will be, let's see, this is 90 minus x, so this angle will be 180 minus 2x, because you multiply 2 if it's at center. So this 180 minus 2x, and this one, these two, will make 180 opposite angle, because these two angles are 90 degrees. So this will be 180 minus 2x, and y is 180 minus 180 plus 2x, which is 2x. So that is this question just illustrated with my mouth. If you don't understand it, I apologize, because this, I can't do anything about it. I hate PDF files. Phew, didn't skip a question. That is a 6-mark question, can you believe it? Okay, question 15. Express this in terms of a bracket x plus b squared plus c. So that would be quite not convenient, of course. That is requiring a bit of thinking. So what you need to do is to expand this form. So let me copy that. I've been talking for a long time and I want water. Yeah, don't talk when you're doing the test, because you'll be screwed up. 2abx plus b squared, I think, ab squared. Yeah, ab squared, then plus c. So we have to identify like terms right now. So we know that this is one term labeled as red color, white color one. Then 2abx is an x term. Then these two are one term because they are constants. And so what we need to do currently is to match A and find B now. So we know that 2x squared is equal to ax, so I don't want it in yellow, A equals 2, okay, so that will be one part. Then now we have to simplify this expression with A, so this is 4bx. 4bx is actually equal to negative 12x, so 4bx equals to negative 12x. So x cancels out, 4b equals negative 12, so b equals to negative 3. Is it? Yeah. So b is negative 3, so now we have these two terms dealt with. Now we need to find the constant at the back, so that is negative 7. So now ab squared is b squared, we know is 9 because negative times negative is positive, times 2, I use a star or an x, let's say. So 9 times 2 is actually 18, but 18 plus c is equal to negative 7, so now we just need to rearrange stuff to get that c is actually a ridiculously large negative number. So c is negative 25. Now you've got ABC, and that is all the question wanted, I think. I just need to write the thing out. The pain of my life, okay. No, I don't want that. So now we know that A is 2, 2A, so A is 2, then X, wait, is it X? Plus B is, well, minus 3, X minus 3 squared, and minus 25, I think. Yeah, that's the answer to that question. So that's simple, quick, and a bit annoying to do, but it's not that big of a deal. I think this is... It's always so nice to see the end of question, so let's finish this question. And this is, I admit, a tricky question. Ridiculously sad for people who can do to powers. This is a complicated one, and I don't even know how I should even attempt to draw it on paint. Seriously? Okay, first thing you do in this thing is we want a improper fraction here, because mixed fraction never work well with powers or surds. So 7 times 9, 63, and 6 plus 1 is 64, so we know it's 64 over 9. So that's some cubics here. Cubic square numbers, I think, not cubic, square numbers here. And we have x to the power of 2 root 3 reciprocal. And so, excuse my poor drawing or writing with a mouse, that is. So that would equal to that. First, deal with this reciprocal. We don't want that, so we change these two around. Okay, so it's 9 over 64 now. So that is one thing dealt with. We don't need that anymore. And now we have to do this. So what we can express x as when it's in terms of a fraction. So x will be equal to the top thing squared and the bottom thing root 3 cube root. And tell you what, you can't really cube root a 9, can you? So actually there's another way of expressing this term. Surds and power can reverse the let's say you can do the power before doing the surd, so it would be a bit easy, I think, to do the power first. So 9 times 9, 80, 81 over that squared is, I don't even know, joy. That is so fun, is it? 64 times 64. I'm gonna do a straight multiplication here, so bear with. So that would be the first part, then the second part will be I hope I'm not terribly derping this up. If I am, then it's my fault for not doing the calculation right. So that would be like that, so you can do your own calculation. Maybe I'm wrong. I doubt that this is right. This 24, 66, 36, 38. Oh, it's actually right, so I'm happy with that. So now we know that is 4096. What a ridiculously large number. I can't believe it. But now that I think of it, cube root might actually be a better choice, but how can you do a 9 cube root? Can you do a 9 cube root? Never mind. So now we need to wait a minute. What am I even thinking about? No, sorry, I'm derping up big times, I think, because this is equal to that. What we need to do is actually to cube it, then root it. Oh, darn me. What a waste of time watching me derp. Well, that is what happens in exams. You just don't know, you forgot things. So the best thing to do is to simplify this to as small as possible and reverse the option. Refuse. Reverse the operation. So we actually cube just normal square root this expression, so that it should be a 3 over an 8, 64. So this is the x squared bit dealt with, so we can just destroy the square, and now we're only having to deal with the cube this expression, which is much simpler than this one. I derped up because the examiner won't possibly, well, the exam board won't possibly ask you to root that. Like, seriously? No. And cube root, it's just ridiculous, so my bad, sorry. So now you have to cube that. 3 cubed is 27, and 8 cubed is 64 times 3 times 8. $512. Why did that take me so long? I can't believe it. Well, you guys have paper and pens, I have brains. So this is the answer to that question. And that's the end for this video, and I hope you enjoyed it. This is part 2 of that paper to look at question 1 to 4, or 1 to 5a. Please look at the first video. And yeah, this is a good paper actually, and I've got loads of time to spend just chilling out in the exam and just stuck my head under my arms, or on my arms rather. It's just amazing feeling. So no, don't listen to me. Actually check your paper and check for careless mistakes. And yeah, so I hope you can get a high grade, if not full marks on this paper, or on the paper you're going to sit, and have luck. See you next time.